Good afternoon, my name is Jesus Perez and today I came to share about this outstanding piece of engineering, the Lilium jet. An aircraft rebuilt in 2019 and it's part of the series of aircraft developed by the German company named Lilium. To be exact, it is the 5th generation, also named Phoenix, of this aircraft concept that has already been subjected to testing. The company has already started work on a 7-seated version with which had projection to be tested in 2022. This aircraft, the Lilium jet, was rebuilt in May 16, 2019, and after it had been developed for several years before that time and had prior flight to the announcement on the 16th of May, you can see how it has been 5 generations of different technology being tried out by this company since 2015. The reasons for the design in this aircraft, I would separate them into the Lilium business strategy and the safety and law approval for the aircraft. As well as we can see that the UAM to the power of 1% challenges, according to the regulators, factors more important for transport vehicles are infrastructure of the vehicle, safety of the vehicle, and the noise made by the vehicle. And I think that the company Lilium has taken this in consideration when building their aircraft. The company aimed with the Lilium jet to the only business scheme and their only business scheme is to provide a service of high-speed form of transport to connect inner towns and cities across ranges between 40 and 200 kilometers range at a speeds of up to 300 kilometers per hour, which is the same thing 186 miles per hour. I would also like to mention that these reasons are also a business requirement for the RAM market, which dictates that a competent aircraft of this type should be able to travel distances ranging from 100 meters to 300 meters and at speeds exceeding the 200 kilometers per hour. The Lilium company wants to make was still making it accessible for everybody, providing an environmental friendly and sustainable solution to conventional transportation means or vehicles to in the future enable high-speed air mobility for everybody. This is called Regional Air Mobility, or in its English abbreviation, RAM. The Lilium team also designed an aircraft jet to demonstrate the mission capability of the Vector Thrust concept, eVTOL aircraft, which can address the market needs of UAM, urban air mobility, and RAM without facing noise challenges the same way propeller concepts do. As I mentioned before, it is important that noise is not as high in the production of this aircraft, or access to populated areas would be denied to the aircraft. So what the Lilium company intends to do is make it so quiet so that it will be equivalent to the sound of a conversation between two people at around 60 dB at a distance of 100 meters from you when the aircraft is in hovering mode, which is quite awesome. The Lilium team also designed the aircraft to demonstrate the mission capability of the DVTC Directed Vector Thrust concept aircrafts. And as you can see, during the 4th of May of 2019, the Phoenix prototype, which is the name of the Lilium jet, first flew, and in October of the same year, and after several tests, it had demonstrated how the capability of the aircraft to transition from hovering stages to climbing segments and then transitioning to cruising was achievable, reaching over 100 kilometers per hour, but not yet fully horizontally. It managed a 24-degree banked turns, high ascents and descents, rates in like the operations, hover turns, and sideward translations as well. Testing was also taking place to mitigate fan and flap failures by the use of electrical and flight control systems, all controlled by the Lilium company. Also fits in hand to highlight that it was stated by Matthews Maynard, Phoenix chief engineer and co-founder of Lilium, that the core elements for the flight control system of the aircraft, such as the flight control laws, software, and algorithms, were all designed by the Lilium company. At the same time, it also appears ambiguous. It appears difficult for such an ambiguous architecture to achieve these stated requirements and mission profiles. And many experts have shown their skepticism, including the technology officer Alasdair McClosh, who, with great experience, showed his preoccupation due to associated fan size and power consumption. But as mentioned, the Phoenix prototype was capable of reaching quite good results during testing, and the development of Lilium and the use of the CFD simulations were included for later data collection and modeling, allowing the creation of extensive aerodynamic data banks to be created. All this was used to build a light dynamic model of the Lilium jet to test and develop all without the need to test on the prototype. I believe that this is one of the factors that allowed the quick innovation and some design features of the Lilium jet. At the same time, we'll establish that the flight profile of the Lilium jet is that what design features and which are Lilium jet core technologies have made this aircraft truly unique, following the principles of one of the co-founders, Matthias Rainer, of maximum simplicity combined with a level of safety. A misconception now simulated to the eVTOL aircrafts is that they should act and behave in a similar manner to the helicopters, capable of hovering for a long time, and in practice this has most of the time been the case. This is due to the 3 of the 4 eVTOL categories relying on propulsion systems based on propellers. But at the same time, the Lilium jet categorizes as dark fan architecture aircraft, following its reason for design to connect cities in regional areas as quickly as possible, like an airliner, which also categorizes the Lilium would. Differences between them is that thanks to the dark fan that acts to mitigate noise, and also that works with the acoustic lines mounted within them that capture and dissipate the noise before it reverberates into the surroundings, it is possible to collocate the fans close to the fuselage and the wings for close aerodynamic coupling. This is similar to what it is used in future aircraft concepts where boundary layer ingestion is applied. A mission of Lilium normally consists in 7 phases demonstrated above. 90 to 95% of the mission time is spent climbing, cruising, and then the 7th phase, in which it is as 10 times more efficient as the plane would during hovering flight. During this more efficient phase, the physics of the Lilium jet resemble a commercial fixed-wing jet. In comparison, the Lilium jet consumes 2 times more as power that a hover would be, that another hover would be equivalent with an open motor concept, such as the Archer Maker, which is another eVTOL. For this reason, it compensates in this by optimizing the cruise flight performance, which, as mentioned, requires 1/10 of the hover power, and it represents 90 to 95% of the flight time. At the same time, what has given the Lilium jet its unique capabilities has to do with electric ducted jet engines. With the Lilium jet counts with 36 of, distributed into 12 flats of 4 flats at the front and on the canard, and 8 flats in the main wing, All flaps are used during the whole flight and for all thrust vectoring that controls the aircraft. This concept is called distributed propulsion system and comes with more advantages, such as controllability, simplicity, and safety, as this system is highly redundant, and in case of failure, the flight control system can automatically distribute thrust and stabilize the aircraft. Simplicity, as flaps only receive two types of signals, the flap angle and fan speed, and controllability, because it eliminates the need for ailerons, elevators, and rudder, as everything is provided by the canards, wings, main wings, and the distributed propulsion system. The embedment of the ducted fans allowed to reduce the drag and improve the cruise efficiency for the fans attached at the back of the wing. During transition phase, constant attachment flow is present. For efficient high lift flow, all allows high controllability, By the other hand, second to best, it will be variable nozzle, which solved a problem in cruising and hovering mode, as the motor itself, it is more efficient for hovering, as it needs 10 times more energy than cruising would. Mechanically attached to the body of the duct fans, they are designed to be more functional during hover flight, and its thrust required it is 10 times the thrust required during cruising. For this reason, the flow fields of the fan change greatly. Reasons for which at the exhaust of the duct fans, the nozzle is used to change the cross-sectional area of the exhaust during the flight for increased levels of efficiency at all stages of the mission. A variable nozzle can optimize the fan flow during cruise, and it is a simple mechanism attached to the fan's body. As the angle of the fans changes from horizontal to vertical, the variable nozzles also change from open to close for a better optimization of power and exhaustion. And lastly, operations for the future. As mentioned, the Lilium company works for the new 7 serial aircraft, so like new 7 seated aerial aircraft, Lilium jet, and it has started development. If it is successful and they get type certification with the EASA and the Federal Aviation Administration, the market entry level they will already have at market entry level, they will already have the highest capability that which is 50% more than the highest competitor right now. So the prototype of the Lilium jet 5-seated sadly was destroyed by a fire on the 27th of February 2020, and a twin partially assembled prototype was conserved. A third unfinished prototype was discarded. So the company is moving on to new contracts such as with the Evolar in the UK, and they aim to build an ecosystem of partners. Thank you for listening.